So today is test review day. So next week we have our first test. So tests 1 and 3 are on the shorter side. Tests 2 and 4 are longer. So next week, just to remind you, and this is all on the syllabus of course, but it'll be 15 definition questions, all of which will be taken from the key terms list, and 2 short answer questions, which you all know roughly what both of those will be. And also, of course, the week after, back to daily quizzes, right? So every day that's not a test day and is not a test review day will have a quiz. So for the first 30-ish minutes of today's class, I'm going to do some housekeeping, go through some things that I skipped over for the sake of flow, and then the rest of the time belongs to you all. It's time to ask questions, ask me to explain things again, or ask about anything that I've missed. So after that, it'll be up to you how long the class goes. And if there is a period where there won't questions, I'll say you're all free to go, but I'll still stick around, if you want to come up and ask questions after. So for chapter 2, a couple terms I missed that, it's implicit in what I said, but external world skepticism and inductive skepticism. So Descartes was someone who, he wasn't a proponent of external world skepticism, but he at least used it in his arguments. So skepticism just means doubt, right? Being skeptical. So being skeptical that there is an external world, right? Doubting whether you're thinking maybe I'm just a brain in a vat. Thoughts like that fall under what's called external world skepticism. And inductive skepticism, of course, then would be skepticism about the validity of inductive inference or induction. When I rewatched, and actually as a general tip, go ahead.
Can I have an example of inductive skepticism?
So Hume, right? So Hume, is an inductive skeptic, right? He argues that there is no rational basis for generalizing from a finite set of data to some kind of generalization. So induction is where you have a finite set of data, you have a set of observations, and you generalize from them. So for example, you see a series of swans in your life, all the ones you see are white, and you inductively infer from that all swans are white. I forgot to mention, this is a famous example in the history of science because it turns out that it's false. It was used as, this is an obvious example of induction working. I believe it's Australia that has black swans. So kind of a nice example of the issues with inductive inference. Another thing that, I was going to give some advice. If you want to improve at public speaking, a painful but effective way is filming or recording yourself and watching it later. Because then it's, that wasn't so good. And then it was a way of me kind of punishing myself, because then whenever I would speak, I would go, I don't want to have that cringe later, so I will stop doing, whatever it is. One thing that I thought could have been, hearing, you've all, I guess, experienced this, so one thing I thought I could have been more clear about, or could have potentially misled you on, the term logical positivism, or the logical positivist, that doesn't include Hume. So Hume, 1700s, was a British empiricist. The positivists, as a movement, started in the 1900s, especially in Austria. So those names listed, Schlick, Neurath, all those folks, those are 1900s, philosophers mainly working in Vienna, at least before the Nazis forced them to flee. A concept from chapter 2 that I skipped because, like I said, I thought it would interrupt flow, is the theoretician's dilemma. So this could be used as an argument for something like positivism. You don't have to take a side on it. There's different rabbit holes we could go down, but you should at least have a sense of how it works. So to set it up, I'm going to take Feigel's picture in the book. I'm going to cut some stuff out and just get to kind of the core of it. So there's the bottom layer, which is what he calls the soil of experience. So these are the kind of raw ingredients that we use to make our scientific theories. Right, so all the phenomena that we observe. And then we use that to make some empirical concepts. Right, so something like, I don't know, apples, whatever. So you see a bunch of stuff over the course of your life. You group the red and green spherical things that come from certain sorts of trees. We call those apples, right? That's an example of an empirical concept. Now, this is not the term in the book, but you can imagine then building up or seeing certain patterns in your empirical concepts, right? Things like, all apples come from trees, orbits happen in a certain pattern. There are certain things that you discover in your observations. And then there's a kind of magic line above which you postulate unobservable entities. Right? So you observe certain patterns in terms of what comes out of the sun. You observe patterns in how subatomic particles behave, or well, I shouldn't say subatomic particles. You observe patterns, and you infer on that basis certain unobservable things like fusion inside the sun. Something you can't see, but it plays an explanatory role in explaining what you do see. And actually, subatomic particles is a bad example because that, of course, is here. So what you would see is, higher level patterns, and you infer that there are things like quarks or electrons or what have you. So does this basic setup make sense? So here's the theoretician's dilemma. Do the unobservable entities play a role in explaining the patterns in our observations? If no, then we can dispense with them, right? If we're good empirically minded scientists, if the unobservable entities don't play any role in explaining the patterns we see, then we can dispense with them. But, now here's maybe the more controversial part, if they do play a role in explaining the patterns we see, we can dispense with them too. We can just focus on the patterns in the observations. In other words, take the sun again, we can just describe the pattern of starlight emanating from what we call the sun. We don't have to talk about fusion. So if the only reason we believe in the unobservables is the role they play in explaining these patterns, well, we can just get rid of them. Just focus on the patterns in observation that you detect. So that's, in short, the theoretician's dilemma, and it, again, could be used as an argument for ignoring unobservable entities.
So the positivists only believed in what was observable, is that correct?
Exactly. So the key feature of the positivists, at least some of the early strict formulations, is you should only talk about, write about what's directly observable. Right? I mean, that connects to the verifiability criterion of meaning, right? Sentences are only meaningful to the extent that they are empirically verifiable. Now, we'll actually come back to related issues in the chapter on scientific realism. One thing I'll just mention, that is something that'll be important when we talk about Bos van Frossen, this line actually moves over the course of time. What we can see is really a function of A, our biology, and B, our measuring instruments. Now, I won't get into that now, but any questions about the theoretician's dilemma?
Is there a difference between what we can see and what we can detect?
Yeah, that exact language is going to come up in the scientific realism chapter. So someone who's a scientific realist who thinks it's perfectly fine to have unobservable entities is going to say, well, yeah, we can't directly see it, but we can detect it, right? We have observational techniques that allow us to infer the existence of fusion in the sun, quarks, or what have you.
And then so the stuff beyond that line, would that be considered the inference of the best?
I'll come to that next. So that's not always. Inference to best explanation could include observable things. I will talk about that. Okay, but before that, I'll stay with chapter 2. So I mentioned the name Quine just briefly. So Quine, you know, the Duhem-Quine thesis, right? The idea that you can't test statements in isolation, right? You have to test them in conjunction with other background assumptions. And I can return to that during the question period because it's a difficult concept. But there's a related idea. It's one of Quine's most famous and by the way, his full name, it's one of the most pretentious names in the history of philosophy. His full name is Willard Van Orman Quine, or sometimes just WVO Quine. So yeah, very, very pretentious name. Maybe Quine's most famous idea is he rejected the analytic-synthetic distinction, or at least said the distinction is not clear-cut. So, reminder, so the analytic-synthetic distinction, similar to the distinction between a priori and a posteriori truths. Analytic truths are truths that you can know purely as a matter of definition, right? Like all bachelors are married, 2 + 2 = 4, and so on. Synthetic, by contrast, you can only know through observation. So the synthetic truths are truths that are, in some sense, true of the world, not just true of your ideas or of your definitions, right? To say that all bachelors are unmarried is really something that's true about the way that you use the terms or about what the concepts mean. So Quine problematizes this distinction for several reasons. One reason that's maybe less important is these first kinds of truths, the analytic truths, empirical information actually does bear on that in the following way. He mentions this in his paper. Facts about what terms mean relate to truths about how people use the terms. So, in the philosophy of mind section, we'll see Wittgenstein. Wittgenstein famously says, meaning is use, right? What determines the correct usage of a term is how a linguistic community uses the term, right? So what does the term bachelor mean? Well, basically, it means whatever how English speakers use that term. And that's, at least in part, the subject of empirical linguistics, right? You have to go and look at how people in fact use the terms. So that muddies the distinction a bit. A more central reason Quine rejected or problematized this distinction is his notion of the web of belief, which I believe is a key term. Here's the way the web of belief works. So there's, I'm not very good at drawing, but there's the kind of outside concepts, and then there will be the middle concepts or commitments. They'll be connected in some way. So like I said, don't be jealous of my good drawing. The stuff on the outside of the web of belief, those are ideas that connect more directly with observation. So I don't know, like apples are red or something. You can just see if that's true or not. As you get, and so the beliefs on the outside are easily changed by observation. Jupiter has X number of planets. You can go and look and find out whether that's true. You can point the telescope, and if you point the telescope and it turns out it's 73 instead of 65, you're going to give this belief up really quickly. Right? You're not going to be like, no, double check the telescope, it must be wrong. It's like, no, we'll just get rid of that. The closer to the middle a belief is, the less likely you are to give it up. That's what's going on here. So, and what Quine says is, at the very middle will be the truths we call analytic. So truths like 2 + 2 = 4, or truths that are just true by definition. Like the law of non-contradiction. A cannot be true and false at the same time. That's going to be really close to the middle. So far that should seem reasonable, but here's Quine's controversial claim. With enough evidence, you could, in principle, change the beliefs in the middle. This is quite a radical claim, but for example, a truth like 2 + 2 = 4, you could imagine a situation with enough evidence, you decide to change mathematics and have it otherwise. And if that seems crazy, Quine speculated that, and it should seem a little crazy, but Quine speculated that quantum mechanics may be an example where we have to change some beliefs that are pretty close to the middle. Like take an idea like an object can't be in 2 places at the same time. Seems like, well, that's just almost true by definition. But in quantum mechanics, they have these goofy states called superpositions, where if you read the math at face value, it says an electron is in multiple states at the same time. So Quine thinks that actually truths that the positivist called analytic are really just beliefs that we're strongly committed to, but we could, in principle, change with enough evidence. We'll be resistant, but we will eventually change them for Quine. So this means that Quine rejects foundationalism, which I guess I mentioned in a few different contexts. Foundationalism meaning that there are some things that we just know for sure, and then we build the rest of knowledge on those foundations. Another key term that relates to the rejection of foundationalism is Neurath's vote. Neurath was a member of the Vienna Circle. Popper said similar things. So this is Neurath's metaphor for how knowledge creation works, or how science works. He says, we are on a boat at sea, constantly rebuilding the boat. So the boat has holes in it, you take a piece off the steering wheel to plug the hole, you see a piece of floating driftwood, you use that to patch something up, but you can never go to a dock, meaning you can never go to a place that's solid, that you can trust for sure. It's very haphazard, trial and error, and you sort of have to work with what you've got, right? You start with the assumptions that you're kind of born with, or that your particular tradition gives to you, and you sort of work with it the best you can. But there's not any kind of certainty or any kind of solid foundation that you can know for sure is right. It's a very nice metaphor. And as I say, Popper has a similar view. Any questions about these ideas? Yes.
What do you do with statements like, when you say at the core is like 2 + 2 = 4, I'm just thinking about like a pregnant lady, okay? And you say like, okay, how many chairs do we need? We need 1. But if that pregnant lady dies in a car accident, you'd say 2 people died. You know what I mean? So it's like 1 = 2, but 1 also equals 1. Like,
yeah, good. Yeah. So I mean, you could imagine something like that being. It might be a little too easy of an example. Like, there's ways of making that work. Like, there's one adult human, and adult humans, or at least bipedal walking around humans, are the kinds that need chairs. But there's 2 sets of human DNA. So if you're clear about what you mean by person or by whatever, then you can say whether there's 1 or 2 of them. But Quine's radical claim, and as always, you don't have to decide whether you agree with Quine on this, is you could imagine enough evidence such that you would change even something as basic as the law of non-contradiction. I mean, this is a bit, I'm kind of talking fast and loose here, but you could imagine a case where, imagine you were just born into a world where every time you took 2 things and moved them close, a new thing appeared. It'd be a very goofy world, but maybe the laws of physics are just like that. Probably the math they would write down is 2 + 2 = 5. You could imagine that being true. It's in our world, 2 + 2 = 4 works very well. That's a kind of silly example of the kind of thing Quine may have had in mind, where you could imagine enough observations to change one of these middle beliefs.
Yeah, it's getting into the sort of possible world type argument, right?
Yeah, that would. Yeah, no. That's a tempting rabbit hole, but yes, so that's one way of cashing out this idea. Yeah. It's probably not how Quine would have, but yeah, it's a way to get at what he's saying.
Is the question around Neuros' boat, is that like at what point is the boat a new object?
No, that's a different one. That's the ship of Theseus.
Right.
So the ship of Theseus, well, maybe I shouldn't go.
Don't
we have lots of time, but it's, you have a ship, it leaves port, the steering wheel falls into the lake, they, go to a new place, they get a new steering wheel, and by, after 10 years, the ship's entirely made of new parts, but someone goes around finding the old steering wheel and the old thing and reproduces a replica of the original, which is the true ship of Theseus.
Since I'm conflating the two ideas, could you explain again what Neuros' boat tries to do?
Good. So maybe it's really bad that because so what I just said has nothing to do with this. So Neurot's boat is a metaphor for how we build theories, build knowledge, etc. And it's saying, so here's a different metaphor, which is Descartes', or at least a Cartesian one. We have a solid foundation that we know for sure. Like, I think, therefore I am. God exists. Some other stuff. And then we discover, that's really bad. And then you build stuff on top of that. In this case, you build something not very good. But if it was better drawn, there's a solid foundation. Neurath says there's no such thing as a foundation you can know for sure. So what's actually going on when you discover things or when you build theories is you're on this ship, this rickety ship on the ocean with water leaking, stuff falling out, and you kind of haphazardly, take this piece from here to put here. You find a piece of driftwood in the water, you put that on. But you can never, as he says, go to dock. You never arrive at certainty. You kind of do your best, make it up as you go. Yeah.
So like from a theory standpoint, saying that you have this unanswered question metaphorically is like a hole in the bottom of the boat, and you have a theory or a plank of wood and you cap it, and then it stops, and you're like, oh, that works.
It works for now.
Yeah, and then later on it leaks again.
It may leak again. You may have to change your assumptions again. Yeah, that's the idea.
But I think I remember something of while simultaneously you have to keep the boat afloat as well, right? Like you need to.
Oh yes. Yeah, that's the.
And that's the kind of thing is that you have to keep all your beliefs sort of still relevant, but also you're constantly replacing and editing it slowly as you go, right?
Yes. Yeah. So yeah, these are what the metaphor is kind of gesturing at. Okay. See no other hands. Okay. So as I say, now we'll move on to chapter 3 and some things I skipped over. So I think someone mentioned this briefly earlier. So abduction, or inference to the best explanation. So this is it's another form of inference, and here's the way you'd formalize it. One, O, and O we use as just shorthand for observation. So you observe something. H is the best available explanation of O. Conclusion, H. That's abduction or inference to the best explanation. Yeah, I talked about fusion earlier. We'll use that. So we observe a certain pattern of energy coming from the sun. That's the observation. We just detect what comes out of the sun. Nuclear fusion is the best explanation of those patterns. Conclusion, we believe in fusion. This is not deductively valid. So it shares that in common with induction. The premises do not guarantee the truth of the conclusion, but this is formally how the inference works. Okay. Next, the Wason selection task. How many of you have seen this in another course? Some of you. So here's the way it works. I'm going to imagine that I had a series of cards on the table, each of which has a letter and a number. To be more precise, a letter on one side, number on the other side. So that you can take my word for it, is true. So this one we know for sure is right. Number 2, we don't know. We don't know whether this is true or not. And that is, if there is a vowel on one side, then there is an even number on the other side. So this one, we're not sure, question mark. So suppose this is the top side of the cards. A, M, 8, and 7. So does this look familiar now?
Yeah.
So now some of you may already know, although even people have heard it before, sometimes forget. The question is, which of these cards do we have to flip over to figure out whether number 2 is true? So take a look, form a judgment. Show of hands, who thinks we have to flip A? Okay. Show of hands, who thinks we have to flip M? Show of hands, who thinks we have to flip 8? Show of hands, who thinks we have to flip 7? This is a very unusual class. So maybe your prior classes have scared you. The standard thing that happens is most people say A. You're all scared because you know there's a trick, so some of you didn't. A is actually right. No one says M, and that's kind of obviously irrelevant. Most people say 8. That's the mistake. That's the trick. Here, most of you said 7, so probably your prior psych classes have taught you that that's right. So the correct answer is A and 7. Those are the two you have to flip. Now, ignoring the strangeness of this because this is a psych class, let's think about the standard answer. The standard answer of the everyday person is A and 8. So 8 is, so A is right, obviously. You know, if there's a vowel on one side, there's an even number on the other side. Okay, we have to check A. If we flip that over and there's an odd number, the rule is wrong, right? And it doesn't matter. 8, suppose we flip it over and it's a vowel. That's fine, no problem. Suppose we flip it over and it's a consonant. Does that matter?
No.
No.
No, right. Because it says if there's a vowel, then there's an even number. It doesn't say if there's an even number, then there's a vowel. So 8 is actually irrelevant too. But 7 is relevant because if we flip it over and there's a vowel, the rule is wrong. Now, why is this relevant to induction and philosophy of science? So this is actually originally what confirmation bias meant. It's come to take on a different meaning, but Wason, when he coined this term, meant not trying to confirm the beliefs you already have or the beliefs you're attached to, but just generally looking for confirmation, a bias towards trying to prove hypotheses right. So the hypothesis here is if there's a vowel, then there's an even number, and you look to these two to try to prove the not theory, but the statement right. You don't instinctively look here, because if you look here, what you're trying to do is find an exception to this. And people don't, without training, kind of instinctively do that. And this may be part of the value of Popper's philosophy is it's kind of a corrective to that human bias, right? It says, go out of your way to look for exceptions. Go out of your way to try to prove an idea wrong. So again, I think this might be one of the key terms. Confirmation bias in Wason's sense is naturally looking to confirm an idea. Not necessarily one you believe to start with, but just something that may or may not be true. You instinctively look for confirmation, not disconfirmation. Okay, one final part of the chapter that I'll talk about. It's kind of a mathy version of the problem of induction. So the problem of induction, stated in one sentence, is there is no rational way of moving from a finite set of data to a generalization. So in science, we do this all the time. We have a finite set of data, and we take that to support, some kind of law of nature or other generalization. So the mathy version of the problem of induction is the curve fitting problem. So you have some data, a scatter plot or whatever, and what curve or function should we use to approximate the data? So for this one, you could do a straight line, but it looks like you could do something like this. And there are different virtues to different sorts of curves you could fit through data. One thing that's just true, that's worth knowing, is for any finite set of data, there are an infinite number of functions that can fit the data. So you could have something really absurd that hit all the data points like this. It would be a hard equation to write down, but you could have something that hit all the data points, and actually you could have an infinity of such functions, all of which hit all the data points. And then the question is, which do you choose? And on a certain reading of the curve fitting problem, there's no straightforward algorithmic way of picking the function. And this is a real problem actually or a real difficulty with picking models. In some sophisticated modeling, there's a temptation to do what's called overfitting. Have any of you heard the phrase of overfitting? So overfitting means you have a model or a function that fits your data really well. It really explains every data point, but then it's probably not going to replicate. It's just subject to the idiosyncrasies of the people you happen to have, and it's not going to be a pattern that's going to replicate. Okay, any questions on the stuff I added about chapter 3?
Could you explain the curve fitting problem once more?
Yeah, good. So, a one sentence definition.
Yeah.
I won't say it's impossible. There is no clear rule for choosing a curve that fits the data.
Okay.
There are multiple curves you can pick to fit a finite set of data. Okay, so just one chapter left to add some stuff I missed, which is the Popper chapter. Okay, so there's one key term listed, Wittgenstein's poker. I guess I'm quite sure this one actually isn't on the test. Merry Christmas, but all that refers to is Wittgenstein, who was another very important, in fact, if you trust polls of philosophers, the most important philosopher in the 20th century. Him and Popper had kind of an epic meeting and almost fight. Popper was delivering a lecture at Cambridge. Bertrand Russell, Wittgenstein, and some other big names were watching. Wittgenstein, as we'll talk about, was basically a philosopher who argued philosophy was a bunch of bunk, and that it's just confusion and misunderstanding of language, and the job of a good philosopher is to show the ways in which philosophers are confused or misusing language. By contrast, Popper thought that there were real philosophical problems. I think the talk he gave was something like, are there philosophical problems? So Wittgenstein, who was a very intense person, got very angry and was yelling and arguing with Popper. At one point had a fire poker in his hand and was shaking it around. Now, accounts differ on exactly what happened, but in the standard telling, he was kind of shaking it in Popper's face, and they wound up arguing about morality, like whether there were real moral rules. And Wittgenstein said, give me an example of a moral rule. And Popper said, here's one: don't threaten visiting professors with fire pokers. At what time Wittgenstein threw it down and stormed out. There's actually a whole book about this fight and kind of the differences between Popper and Wittgenstein. I think it's literally called Wittgenstein's Poker. That's more for fun, but don't worry too much about that. I think I already made the joke that in academia debates are very intense because so little is at stake. It's true. I wanted to clear something else up. So Popper, of course, wanted to distinguish science from non-science. A term I didn't define was problem of demarcation. This is the problem of demarcation. What is it that distinguishes science from non-science? And Popper's answer is? Falsifiability. Good. If you didn't get at least that out of the lecture, I'd be a little sad. So falsifiability. So if the theory can be proven wrong, it counts as science. Now there's another term, which is pseudoscience, which is a specific type of non-science. So non-science is more broad. It just means stuff that isn't science. Popper is often misunderstood on this point. He didn't think all non-science was bad. As I said, he thought metaphysics was perfectly fine to engage in. Not to say that there isn't a lot of bad metaphysics, of course there is, but pseudoscience, so pseudo means, what does pseudo mean? Like
Almost.
more like fake, kind of like fake, whatever. So pseudoscience means kind of like fake science. So if you want a definition, it's non-science that is pretending to be science. So standard examples are like, creationist science, astrology, things like that, at least to the extent.
Come on there.
This is my go-to example on research methods. I always get some pushback on that front.
Now, we were just talking about astrology in core class too.
Oh yeah, there you go. Now, the best defense I think you can make of astrology is maybe it's not claiming to be science, and then I guess it's, well, I would still have other objections, but at least if it's not claiming to be science, then it wouldn't be pseudoscience, it would just be non-science.
There you go.
In any case, so pseudoscience is non-science pretending to be science. I'll hold myself back from talking about it.
I don't care. I just had to.
Okay. Maybe at the end. So the next term, and I did get at this a bit, but I want to add a little. So the spectrum of theories from weak to strong. I don't think I used the terms weak and strong in class, only verbal and mathematical. So this comes from Armando Machado. So as the term indicates, this is a spectrum. And theories on the strong end are more well-defined and typically cashed out in terms of mathematics. So like Newton's laws, classic example, right? The terms in the theory are well-defined and they lead to specific predictions. Like the rate of fall should be exactly this. Weak theories are typically not stated in terms of mathematics, right? So I gave some examples from psychology, like Loftus's theory of constructed memory. So if you had to state Loftus's theory in short, you wouldn't state it in terms of equations. All you say is, the theory says that memory is influenceable by subsequent experience and is the product of ongoing construction, something like that. And it won't lead to predictions like, the rate of memory change should be exactly this. It just says, subtle cues after should have some effect on the memory. Some effect greater than 0 is all the theory really allows you to predict. So that's what's meant by that spectrum. So as I say, you have access to the video list. I was going to read a passage from Popper. If you scroll through the videos doc, you'll see it's just one of his good quotes. Someone mentioned to me that they've started taking a look at the Conjectures and Refutations book. Very clear writer. A lot of philosophers specialize in making things obscure. I think you'll find Popper is the opposite of that, which is especially impressive because he was writing in English, his second language, and is still a very clear writer. Okay, so that's all the stuff I have to add. As I say, the rest of the time is yours. You can now ask any questions about chapters 1 through 4, maybe about astrology. Yeah.
This was more a question kind of on how you're looking for definitions of people and what you're looking for us to talk about for the just names that you've brought up on the test.
Yeah, good. So here's what I'll say, and maybe this is being too nice. It is unlikely you will see names on the test.
I was about to say, terms, yeah, but I doubt we're gonna
Now,
tell me what Karl Popper did.
It's worth being ready for them. I mean, the chance isn't 0 for all of them, but if a name was to appear, their core idea or what they're known for. Like, I don't want birth year or anything like that.
Yeah.
But
How many children?
yeah, how many children?
What's their star sign?
Yeah.
What's their star sign?
What's their horoscope?
Wittgenstein is such a Leo. I don't know.
Because like different chapters will have people
Yeah.
listed twice. Would you want like because like I don't know.
Oh,
So
are some of them listed?
Descartes was listed separate ideas kind of for chapter 2, but different ideas. In
Good. So
chapter 3.
actually, yeah, that makes sense. So if a part of the function of the key terms list is to guide what you focus on as you study, so that's probably why I wound up mentioning Descartes more than once. But yeah, so I would say for the sake of studying, know what their big idea is, but don't worry too much about the names. And there was a sigh of relief in the room.
So would analytic truths be analogous to necessary truths, and same thing with the synthetic and the contingent?
Yes, analytic truths are the ones that philosophers are going to say are necessary. Now, okay, here's what I would say. Most philosophers would say all analytic truths are necessary, but there may be some necessary truths that are not analytic. So some philosophers, I don't think I would subscribe to this, but would say, everything that begins to exist has a cause. That's not exactly true by definition, but it seems like, well, it just got to be true. So there may be necessary truths like that. Now, if that gave you all a headache, that's definitely not testable. But if you're curious, that's how those would relate.
Another term, open society was in the term list. I don't remember getting it.
Oh, good. So that refers to Popper's political philosophy. Basically, that it's an anti-authoritarian philosophy in which political policy should be continually tested. Would be the yeah. If you want one, it's an anti-authoritarian political philosophy in which ideas should be continually tested. You wrote a book called The Open Society and Its Enemies. Fantastic book. Yes.
So for the term logical positivism,
Yep.
that's like a very big theory.
Good.
Or
Yeah.
it's like a lot of stuff. So like what exactly would you like us to tell you about?
Yeah, if you wanted, again, to condense it down to one thing, I would say philosophy, and since it is broad, you could say a different subset of the ideas and I would still probably accept it, but the core of it is philosophers who thought we could only know things through observation or things that were true by definition. That would probably be the center of the bullseye.
And so for those types of ideas, there's sort of broader understanding of the sort of, as long as we're getting at the idea, that'll be a path.
Getting at the idea,
Okay.
I would say try to get at the center of the
At the
bullseye
center, yeah.
if you can, but probably it would be acceptable if
Yeah.
it was something
We're off
like-
the mark by a little bit.
Yeah, but as long as it's still something like true about what they
Yes.
did or thought. This is the benefit of being near the
It is.
music classes. There's never complete awkward silence.
Did you say open?
Oh, and sorry, if I'm looking away and you have a question, just make a noise. Which I said that to my intro class once. Like, if I don't see you make a noise, and someone made a bird noise, or I just mean like, saying my name.
That's fair.
Last class when you gave us a hint on the written question, you said explain the issue with holism and or like auxiliary. But then you said something like, and the problem with Popper's
Modus tollens, yeah. So modus tollens is this. And I say if H then O for simplicity's sake, but it could be anything. You could say if A then B. I'll stick with if H then O for simplicity's simplicity. So if H, then O, 2, not O, conclusion, not H. So that's modus tollens. Popper, this is the central part of Popper's philosophy of science. Popper says this is how science works. You have the hypothesis, and that you just make up. You just guess it. And then you figure out, well, if that guess is true, what would follow from it? So if Einstein's theory is right, then we should observe starlight here, not here, right? It should be curved by the sun. So you look. Now let's say that we didn't see that. We didn't see what Einstein would predict. So that's not O. Well, then Einstein's theory is wrong. Right? And that's just logic. There's no induction, no generalizing. It's just, as a matter of logic, if these two are true, it implies this. So, yeah, so the question is about how auxiliaries relates to this. And the short answer, you'll have to expand a bit, but it's never this simple. H alone never implies O. It only implies O with other assumptions. So in the Einstein case, it implies O if the telescope is working, your other assumptions are right, etc. Then it implies you should see the starlight here. Yeah.
Can you explain modus tollens without the say formula of premise and conclusion?
Oh, it just is. So modus tollens is this.
It is that.
Yeah,
It is that. Okay.
Yeah. So I could say it without 1 and 2, but it'll be the same thing. It's just if my theory is true, I should observe this, and then I don't observe it. Well, my theory is not true.
So the problem with that is that if it's not O, it may not be just that it's not H, but your background assumptions and
Exactly. So you actually
are
can't.
not true. So you can't
Yeah.
necessarily just say that it's not H.
Exactly. You can't go straight to not H because really it's this. It's if H1 and H2 and it'll actually be many more than that, but all these background assumptions are true, then we should observe this. I'll give the there's the psych example I gave on the first day, or the first real day. So H is anxiety reduces cognitive reflection. So I get a group, randomly assign them to 2 groups. I tell one group, you got an F, because I do it with this class. Tell the other group, they got an A. So based on this hypothesis, I predict that, so I'll say CRT, cognitive reflection test, this group should have lower cognitive reflection test scores than this group. So now, does this imply that we should see this? Not on its own. You have to assume that this causes anxiety, which it may not. Like I said, it might cause anger or some other emotion. You have to assume that this measures cognitive reflection, which is controversial. You have to assume the sample is representative. There's all sorts of other assumptions that might be wrong. So if we didn't find this, so let's say we find that actually they're exactly the same. So does that refute H? Not necessarily. It might be that the anxiety induction didn't work. Or it might be that this is a bad measure of cognitive reflection. Now, what I think we should learn from Popper, though, if you keep blaming these over and over again and never H, you're doing something fishy, right? So if you do a bunch of studies like this and every time there's nothing, and you go, but this is still true, I think Popper's right. At this point, you're not really doing science. So anyways, I've gone a bit off what the original question was, but that, I'm sure, should be, yep.
Do you want us to include reference towards psychology for this?
No, you don't have to. No. So you could use an example. It's one option, and you don't have to use an example either, but I mean, there's an argument for use the time you have. You guys have more time than you need. You know what it is, so you know, there's an argument for that. But no, you don't have to use a psych example.
And I guess to go over that, if we kind of go over the definition, but the kind of core element is in there.
What do you mean?
Like if we,
What do you mean over the definition?
Sort of as you just did, where you kind of extend beyond what the base concept is into sort of things that aren't quite related. But then if the kind of core idea is still present, that'll be okay.
If this is what you're asking, if you say extra true things,
Yeah.
I'm not going to take away marks as long as the right answer is in there.
In there, yeah.
Yeah.
Okay.
Yep.
So the holism, like this whole thing, is also part of the problems with positivism,
Yes.
and that's also one of our written questions.
Good. So that's a good question.
We allowed a double dip there.
I would not recommend it because you have lots of other options.
Mhm.
Yeah, I don't know if I've had anyone. So yeah, I wouldn't recommend that as a strategy.